take over, and that's powered by a single Merlin vacuum engine, also known as the MVAC for short. And topping it all off is the payload fairing, a 17-foot wide carbon composite shell, and that protects the payload during the uphill trip through the atmosphere. About 3 minutes into flight, both halves of the fairing will separate and parachute back to Earth. And if recovery goes to plan, the fairings will be pulled from the ocean and prepped to fly again. Both of today's fairings are actually flying for the first time. Now back to today's mission. Just over the T-minus 40-minute mark, everything is still on track for liftoff. So let's check in with Megan for more on today's mission.
All right, thank you all. Let's start by talking first about NASA's IMAP. It's about the size of a hot tub and weighs a little less than a compact car at nearly 2,000 pounds. There are 10 science instruments on board, and the instruments will work together to map the heliosphere.
NASA's Interstellar Mapping and Acceleration Probe mission, or IMAP, will study the giant invisible shield surrounding the solar system, called the heliosphere. The heliosphere helps make life possible on Earth by protecting us from dangerous cosmic rays coming from across the galaxy.
The heliosphere is our home in the galaxy. It's really important. We couldn't live without it.
The boundary of the heliosphere, located around 11 billion miles from Earth at its closest point, is hard to study. But that's changing with IMAP. As a modern-day celestial cartographer, IMAP will fill in the blank spots on our map of the heliosphere and help us understand fundamental processes happening across our solar system. The spacecraft will be stationed at Lagrange Point 1, a location approximately 1 million miles from Earth toward the Sun. From that vantage point, IMAP will study our heliosphere, as well as measure the constant stream of particles coming from the Sun that can endanger spacecraft and astronauts.
That can allow us to give a half-an-hour warning to astronauts on the space station, to the power grids, so that they can take precautions to help protect them from the damage that might happen from space weather.
The only precipitation I guess we got to worry about is what comes from the sun blasting our way, but we've got a whole team of super duper smart people that are tracking that stuff to give us fair warning.
IMAP's measurements will give scientists a more complete look at our heliosphere than ever before. It will also help us better prepare for dangerous solar particles and radiation that are headed toward Earth. This information will be essential for the future of human exploration as astronauts venture to the Moon, Mars, and beyond.
So, Kelly, let's talk a little bit more about how space weather can affect our astronauts. It's those high-energy particles, right, from the sun that can pose serious health risks?
Yeah, that's really the issue. When they're in really high doses, they can cause radiation sickness and long-term cancer, or even very acute radiation sickness.